Okay, in this video I'm going to give you some examples of VoIP calculations, and I hope this helps out with the current homework. What I'm going to do is I'm going to start with the table from the Cisco document, and I'm going to go ahead and look at G.726. Okay, and I'm going to take G.726, and I guess I'll start with the 20 byte 5 millisecond variation of G.726. So let's start off by writing down the size of the sample in bytes, and so we're going to call that the length of the sample, and that's going to be 20 bytes. And I can put 20 bytes per sample here if I want as the unit. And I am also going to write down the sample period, or the time it takes to get one sample, is 5 milliseconds per sample. Okay. Let's see. We can immediately tell that the codec rate is equal to, well, the codec rate has units of bytes per second or bits per second. We ultimately want bits per second, but I can write 20 bytes over 5 milliseconds. So I put the amount of data per millisecond there. And I get 4 bytes per millisecond, or 4 kilobytes per second, because a milli in the denominator becomes a kilo in the numerator. And because a byte is 32 bits, because a byte is 4 bits, a byte is 8 bits, 8 times 4 is 32, and I end up with 32 kilobits per second as the coding rate. Okay, so that's the raw rate at which the codec generates data. Okay, so those numbers are just the codec. Now we have to put these samples into packets, and we have to decide how many samples per packet we're going to work with. And well, you can see on the 20 byte 5 millisecond we've got a 32 kilobit per second. Okay, so I just did that calculation for you, basically just dividing these two numbers. Now we got to look at how many samples there are in a packet. And if you see here, the voice payload size for in bytes is given as 80 bytes. And that means that there are 4 samples per packet. So there's 20 bytes in a sample and 80 bytes in a packet. That is the payload size. And similarly, the same ratio of 4, the sample codec interval is 5 milliseconds, and there's a 20 millisecond time interval of voice in the payload of a packet. So I'm going to take K is equal to 4 samples per packet. And now I can do some more calculations, and I can calculate, for example, the size of a packet. And I believe we called that LP here. Yeah, packet size is LP. The packet rate is RP. The packet interval is TP. Okay, the packet interval is just the inverse of the packet rate. And then sort of the trick is that when I go to look at the length of the packet, I use LP as the length of the packet including the header. And so it's LP minus H that is the length of the payload, the voice payload of the packet. Okay? And so it's straightforward. The length of the packet minus the header is K times the length of a sample. And the time for a packet, that is its packet period, is K times the time of a sample. Okay? And therefore we can calculate the length of a packet We also have to know the header now, but we can calculate the LP minus H as 4 times 20 bytes, and that gives me 80 bytes. The same as on that spreadsheet or on that Cisco document. And the time for a packet is 4 times 5 milliseconds, and that's 20 milliseconds. Okay. Finally, if I'm given H, so let K equal 4, and now I'm going to let H equal 58 bytes. Okay, and this is the case of RTP over UDP over Ethernet, over IP over Ethernet. Okay, and now I can write that the length of a packet is H plus KLS, which is 58 plus 4 times LS, 20, which is 58 plus 80, so it's 138 bytes long. Okay, and now, you know, I can do some other calculations here. I can do things like calculate the overhead, and I can calculate the overhead as a percentage, for example, and the overhead is 58 out of 138. Okay, so that's some percent. 58 out of 138 is on my broken calculator, 0.42, so it's 42% overhead. Okay, I can also calculate the time it would take to transmit this packet using let's say 100 megabit per second Ethernet, fast Ethernet. Let's transmit this packet on fast Ethernet. So the rate of that fast Ethernet is 100 megabits per second, and therefore the time it takes to transmit this packet is going to be the length of the packet divided by that data rate. Okay, so the higher the data rate, the larger the denominator and the less time it takes to transmit. So 138 bytes times 8 bits per byte all over 100 times 10 to the 6th, and I think I'll use my calculator for that also. 138 times 8 divided by 100 is equal looks like 11.04 times 10 to the minus 6, so it's something like 11 microseconds. Okay, and so you can see here that it took us 20 milliseconds to capture that data, but it only took us 11 microseconds to send it out. Okay, so hopefully that serves as a nice example for your homework, and I'll leave it at that. Thanks for listening.